I have been to Korea 15 times, and in that time, it's always been winter. I hope that we find good cause to do business in Korea, because I would like to come back in the spring sometime. So I'd like to start off by talking a little bit about BigSwitch and our company vision, so you have some understanding of why we're doing what we're doing. The compute and the mobile industry went through a transition from closed architectures to open architectures, and opened the door to a wave of innovation. Compute went from a closed proprietary world of big iron to a more open, yet still smaller system closed world of Spark and power processors running AIX and Solaris. And then Intel came along. They were around, but they really hit it with battery died. They came along with faster and cheaper chips. And this guy named Linus wrote an operating system called Linux. And that really changed the world. On top of Linux, we evolved an entire plethora of software based on open standards. We ended up transforming today from what we see in large-scale compute services, available for the smallest companies and the newest startups. It changed the world. There would be no Google, no Facebook, no Yahoo without open software and open hardware. The result of this transformation was increased unlocked customer value, new companies, profit and growth, and jobs. In mobile, we had a world of closed hardware. Hardware companies made phones. Phone companies dictated the software that went on those phones. And let's face it, that software was pretty crappy. Then along came Apple. And Apple said, hey, we've made a phone, and you can't put your crappy software on it. And furthermore, we're going to open up the APIs so third-party developers can write software for it. Google, with Android, did one better. They said, hi guys, here's an operating system for your phones. And we're going to let you develop apps on it. Think about it. How many companies have been created? How much value has been unlocked? How many jobs have been created? How much revenue has been generated? Because Google and Apple allowed somebody to write Angry Birds. Samsung. I have a Galaxy Note 2 there. Korea's success, the success of Samsung, and a lot of the things they do are directly responsible of this open architecture movement. Then we come to networking. Cisco Catalyst 6500. What happens if you want to run a firewall on that? You write a check to Cisco. If that firewall doesn't do what you want, what if you want functionality provided by a third-party vendor, like Palo Alto Networks? You can put it in line, but it's not the same as running it on the platform. We at BigSwitch believe that today, the next model, the next change, is the unlocking of the closed system of networking. And that our open SDN approach will provide the same transformation that the open compute hardware and the open mobile platforms did. That's what we're trying to do. The OpenFlow controller platform technology that we use dates back to 2007. at Stanford, where Guido Appenzeller, our founder and CEO, was part of the team that developed OpenFlow at the Clean Slate Lab at Stanford. In 2009, one of the first papers on network virtualization was published under the name FlowVisor. The person that helped write that software was a gentleman named Rob Sherwood, who works at BigSwitch and is head of the ONF Architectural Committee. In 2010, Guido, along with Kyle Forrester, founded BigSwitch. And in November, we announced the availability of our first products. If you're going to build a company, it's important to have people that know the products that you're trying to sell and have experience at selling them and building them. BigSwitch benefits from the experienced team and has been part of 3 major critical trends in networking. We have veterans from Cisco, Arista, Juniper, and VMware. I'd like to call attention again to Guido, who is one of the authors of the OpenFlow standard. Howie Zhu is the gentleman that led the development of the vSwitch, along with an author of the VXLAN standard, distributed vSwitch, and led the partnership with Cisco in creation of the Nexus 1K. Mansoor, a longtime friend of mine, comes from Arista as well as I do. Kyle ran the wireless group at Cisco. Turns out that wireless has a lot to do with SDN, when you really think about it, because the wireless industry has had the idea of a controller for a very long time. And finally, Dave Butler and Jason Madoff, they both come from Cisco and from Aruba. The next thing you need to look at about whether a trend is real is who puts money into it, right? The venture capital firms bet money on what they think's new. So on our board, it's important to note that we have Michael Mobley. Michael ran the routing and switching business at Cisco. Charlie Giancarlo, Chief Development Officer at Cisco. Satish, Cloud.com. Aruba. And even Mark Leslie, who was on the board of VMware. And one of the more interesting trends up here is Goldman Sachs is not only an investor, they're one of our first clients. The Goldman investment team came down to their IT team and said, hey, have you heard of these guys, BigSwitch? What do you think? And the IT team said, yeah, we're talking to them. We've deployed their stuff. It really works. And then they called us and said, we'd like to give you money. That was a good phone call. So, what are we talking about? SDN relies on this idea of this 3-tiered architecture. You have the controller in the middle that orchestrates the data plane, physical and virtual switches, and you have the applications on top. So at BigSwitch, our controller is based on an open source core, a project called Floodlight. I'm sure most of you are familiar with it. We've counted more than 10,000 downloads of it since January. At the bottom, we have a partner-driven southbound API. We support physical and virtual devices. It's very important that when looking at SDN, that you acknowledge the fact that you need to speak both to the hypervisor, the virtual switch, and the hardware. It is a complete picture that you need to deal with. We have 12 physical and virtual switch products that we've done interoperability testing with. On the northbound side, we have 2 of our own applications. We have 5 partner applications. And we have 7 applications on the roadmap. I won't be sharing those, but if you'd like to talk about it later, please come up to me. So what are these products? Big network controller in the middle is the base for our network application platform. It's built on Floodlight, and we add enterprise APIs. At the top, the first 2 products are Big Virtual Switch for network virtualization and Big Tap for network monitoring. We have a complete partnership for accelerating the adoption of SDN. On the southbound, we work with every switch vendor. And if Cisco would like to give us a switch, we'll test interoperability too. Cisco, if you're listening, please. On the hypervisor side, we've tested and worked with all the partners. On the northbound side, there's a huge group of companies that are developing solutions and working with us. And working with our APIs to develop solutions based on SDN. So let's talk about the first product, Big Network Controller. Big Network Controller is based on Flowlight, which is open source. Around that, we've added the things that enterprises require. Topology management, high availability and scaling, selective broadcast, enterprise integration, and statistical analysis. These are the things that the enterprises crave in order to be deployed in a network. We include enhancements to the core that increase the performance and scale, and make the controller aware of layer 4 to 7 events and able to react to them. We can track the endpoint of host on bare metal. We can track the movement of VMs and pre-programmed flows to take advantage of that. We provide a CLI, RBAC, and we expose statistics. Our enterprise controller helps support multi-tenancy, high availability, it's tunnel aware, provides for waypoint routing, provides for ACLs, VM migration, and fast reflow of flows. All right, so what does all this mean? These are the marketing slides. At the heart of it, I'm an engineer. I hate all this stuff because it's very fluffy. I've added a slide now that shows what this really looks like. Not marketing approved. I'm sure we're going to hear about it later. Bit of tech. We have a CLI. It's important to note that the CLI is just a REST client. Looks like a Cisco CLI, just like everybody else's. The network gentlemen will be familiar with it, and they'll feel comfortable. One of the most interesting things about this is that you can type this command, debug REST, and then every command that you execute, it will print what the REST calls are. If you're trying to design automation or workflow, it's a nice way to cheat. So what does this command do? Show link. Well, I ran this. This is the output of BigSwitch's production network. And I see a list of switches. There are 4 of them. And it shows which switch is connected to each other, on what port, and what the mapping is. It seems pretty boring. But think of this. How do you do this on a traditional network? If I have a traditional network, how do I actually figure out what's talking to each other? I log into every switch, hope that somebody configured LLDP, hope that somebody named them correctly, and then type show interface, type show LLDP neighbor, and then grab a piece of paper and draw out what the connections are. The reality is that's a pain. This, one command, 3 seconds, I know what the network looks like. A little more tech. Debugging made easy. Show flow cache. To be honest, this is about 20 other items. I cut it down to make it fit. Red is source, green is destination. With one command, I can see the packet flow on a network, no matter how complex, from end to end. I can see where it came from, where it's going, what the protocol is, and where it originated. Once again, how do you do that in a traditional network? Well, I log into every switch in between, and I hope that I can find the right host. I have no information on what the protocol is, I have no information on what port it is, and I have no information on where it came from. This seems simple. The slide's not pretty, the information is a lot, But it turns out this piece of information is something that you cannot get in traditional network design. And it's something that the people that run the networks spend hours and hours, time and money, trying to do. The promise of SDN is visibility and simplicity. Show host. Once again, this is from the BigSwitch network. You can see I have something called an address space. Address space is just a separation for big virtual switch. And I have a flat 10 network here. I've got some phones, IP phones, and I've got some office ports. And I know where they're attached with one command. I know what their MAC addresses are. I know what IP addresses they DHCP'd. There's something a bit interesting in here. There's a VLAN column. SDN does away with VLANs. Why is that there? Well, it turns out that we don't live in an ideal world, and I just can't say everybody go to OpenSDN now. I have to integrate. So one of the things that we do in our enterprise controller is we realize that you have to plug this into non-OpenFlow networks. And we design software that allows you to compensate for that. So in this case, the phones and the office network plug into a traditional firewall. And the firewall expects to see packets from the phones, tagged with VLAN 8, and expects to see packets from the desktops, tagged with VLAN 16. And there's a command in the controller that basically says, hey, if you're taking a packet from any of these devices, and you're sending out a port that's non-OpenFlow, go ahead and tag it. Very simple integration. Anyways, that's it for the tech. Back to the marketing slides. The first application that I'd like to talk about is Big Virtual Switch. I'm going to show 2 slides that show you the exact same thing in a different view. This is a classic data center design. This is how you look at it from an application standpoint. I have some web servers, I have some app servers, and I have some database servers, and they're on separate VLANs. The network guy sees a series of racks and a series of subnets, and he deploys them that way. And what you end up with is what you have here on the right. Servers that are not fully utilized. It's a waste of money. Here's the second view of this, the workload view. This is the way the people that are asking you to help them with their business view things. This could be your accounting department. This could be your marketing department that wants to crunch numbers for an advertising job. All they care about is, I need 6 application servers, 3 web servers, some database backend. I want to secure it, and I want to process some data on it. But once again, the network gets in the way. The physical view comes back to the traditional model of spreading the applications out on specific tiers and specific racks and specific VLANs. And frankly, it's very complex. This complexity leads to the inability to auto-provision and isolate workloads and to share layer 2 to 7 services. This costs money. So classic network design causes stall projects, stall automation projects, because you have to figure out how to take your ideal workload and deploy it on something that is not designed to work the way you want it. Stranded compute capacity. VLAN limits don't allow you to use your service to their fullest. VMware may have revolutionized the data centers by allowing you to grab spare CPU capacity and consolidate your servers. But it turns out you really can only consolidate the servers in a single department or a single application. You can't actually share that resource across your entire enterprise. Calendar days to deploy workloads. Well, what do I mean by that? Very simple. Back in the old days, before virtualization, if I was a network guy, the server guy said, hey, I've got a mail server. I handed him a cable, he plugged it in, and I knew what traffic was on that port. Today, it's running a hypervisor. I have no clue what traffic is on that port. I have no clue how to provision it. I have no idea what VLANs are going to go on. I have no idea what the security policy is. It's complex. On average, it takes 15 calendar days to deploy the networking portion of something the VM administrator can deploy in 30 seconds. I have customers that we've shown this to, and they start laughing. And they say, 15 days, it takes us 30. You're being optimistic. Trouble tickets. Virtualization was supposed to cut down on the headaches and the calls to the help desk. Turns out that once again, when I consolidate services on a server, I lose my visibility. It's no longer just a mail server. It causes a huge increase in the number of trouble tickets. It didn't solve the problem. It made it worse. The reason it's worse is because nobody bothered to virtualize the network underneath. So here's what we do. Big Virtual Switch delivers network virtualization by programming the desired network topology into the physical and virtual switches without requiring virtual networks to correspond to the underlying physical systems. We define a virtual network segment on top of the underlying physical switches and infrastructure and provide a flexible network partition. The virtual networks correspond directly to groups of virtual machines or resources that you would like to share. By creating these resources, we can dynamically increase the data center resource utilization, dynamically reduce capital expenditures, and compute workload, on compute and workload deployments. The fact of the matter is that this model fits with the workload model that I showed you before. I grab resources and I share them. I take a port from the switch over here. I take a vSwitch from a hypervisor over here. I take a resource from a firewall over here. And I say, that is accounting. Or that is Cloud Company 7. I define my resources and share my resources by their purpose, not what the underlying network dictates. We can do this whether you use an L2 fabric, an L3 fabric, or a pure OpenFlow network. We are agnostic to this. Whatever your underlying technology is, we will support it. Of course, the problem here is nothing always works for everybody. Requiring every switch to be an OpenFlow just isn't going to fly day one, as much as we would like it to. Our solution is designed to provide the most benefit with the fewest constraints. There are three models: pure overlay, hybrid, and OpenFlow. Big Virtual Switch is the only SDN product that can play in these. What does this mean? Well, pure overlay. I have an existing network with existing hypervisors, and I have non-SDN network switching. What do I do? Well, pure overlay means that you create tunnels from hypervisor to hypervisor, and you're able to move a workload around. It allows you to take an existing legacy network and apply the workload model. And this is really neat, and it works very well. There are issues at scale. We've addressed a lot of those. But let me ask you something. Does everybody have a pure virtualized server infrastructure? Do you have a NetApp or EMC that you share files on? What about that legacy database server that's running on bare metal? The problem with the pure overlay model is it doesn't take into account the reality of what your network looks like. So in the middle, we have the hybrid network. You do overlay. And then you say, look, you have 10, 20 ports of bare metal. Buy an OpenFlow switch. Plug it into that. Big virtual switch, because of our ability to control both the virtual switch and the physical switch, allows you to incorporate those legacy services, those non-virtualized services, into your network design. And then the ideal model, of course, is pure OpenFlow. Everybody in this room hopefully has religion about OpenFlow. They understand why it's important and how it works. I spent 4.5 years at Arista, fantastic company, and I covered Asia. And I went into a lot of meetings and I kept hearing, OpenFlow, OpenFlow, OpenFlow. You know what? This stuff is a fad. It's never going to take off. Right? I didn't believe in it. And then I actually got access to the BigSwitch controller with their partnership with Arista and tried it out. And I looked at it and I played with it. And I went, wow, this changes everything. And I work at BigSwitch now, so. The reality is, OpenFlow allows you to reach into the networking hardware, grab a packet, and do whatever the heck you want with it. It truly changes everything from a design standpoint. Traditional network design dictates that you have a server, the top of the rack, an aggregation layer, services, firewall, load balancing, router. It has to be in the path, because the path is dictated by the traditional networking protocols. In a pure OpenFlow model, that doesn't apply anymore. Those firewalls and load balancers, those services, that very expensive piece of equipment compared to the switches and routers that you buy, should sit in a rack and be a shared resource. In a pure OpenFlow model, you could have a VM in a rack that tries to access the router on the internet, and you can apply a rule that says, well, Mr. VM, you're allowed to access the internet, but your packet must first go through a firewall that's in this rack. And the controller can push down those rules so the packet leaves the VM, goes to the firewall, and then goes up to the internet. That resource is not in line. It does not have to be scaled for every packet that goes through it. Take that one step further. We all know what an established session is, right? In a firewall. I saw the traffic, it's good, I'm going to allow it through. In order to do that, does the firewall need to see every packet? What would happen if the controller sent the first packet of the flow to the firewall? The firewall says, yes, I agree, this is established. And then told the controller, don't send me the rest of this. Only send me new sessions. You can touch the packet. You can do what you want with it. The problem, of course, is in pure OpenFlow, the table size on the switches is just too small. The current OpenFlow switch platforms, which are generally all based on the Broadcom Trident chipset, can handle flow sizes up to about 1,500. Not really interesting. It turns out, though, that some of these switch vendors have decided to unlock other tables in their TCAM. And one or two of them are showing devices that can do 96,000 flows. And that's today's generation. At 96,000 flows, the pure OpenFlow model becomes very interesting. If you back up to the idea that I was just talking about, the ability to reach in and touch the packet, and you understand that, then the third model is really what you're interested in. The surprising thing that we found at BigSwitch is that we start out with customers talking about the pure overlay model or the hybrid model. And somewhere in the middle of that conversation, the customer says, well, why don't I just go the pure OpenFlow model? The adoption of something like that truly changes the way we build networks. And it is my personal opinion that we are going to see that happen faster than any of us expect. So, I talked about deploying workloads, right? The reality is you need to be able to have an orchestration layer to do that. And that orchestration layer has to be able to talk to the network. So at BigSwitch, we've done work with the Quantum plugin on OpenStack. And we've enabled our big virtual switch application through the OpenStack UI. So today, you can install OpenStack with the Quantum plugin, install big virtual switch, and enforce the isolation of tenants and VMs in a flat network automatically. We're working with Citrix on CloudStack. I have a very interesting demo available now. If any of you have seen CloudStack, it has the little drop-down. It says VLAN GRE for enforcement model. Oh, we have a version of that added BVS, Big Virtual Switch. And we've tested and worked with vCenter, and we can enforce isolation on that. So what we're doing really, and the thing that people want, is we're marrying the virtualization tools for servers to the underlying network. Why do we care? Money. It's always about money. This is a study based on HP Labs and Gartner. It's validated with real operating code. Here's the math, and it's very simple. You get 50% more VMs per rack by using BVS. When you can put the VMs everywhere, regardless of their IP or VLAN association. In today's model, you keep a lot of spare space. You never run up to 100%. You don't want to fill your subnets, and you don't want to run out of VLANs. All that stranded compute capacity costs you money. 50% more VMs per rack requires that you spend less on CapEx and less on OpEx. If you're operating an enterprise data center, 200 VMs per server, or public cloud, 1,000 VMs per server, the cost savings, which you see here, can be quite significant. We're not making this up. This is math. You pay for hardware, but you pay for power and cooling every day. The cost of the hardware is immaterial to the fact that you have to keep it powered on and support it. If you can use that resource more efficiently, you save money. It's very basic. So the other application that we have is called BigTap. And it's the idea of a unified network monitoring application. So, traditional network, once again. 3 layers. You have some tools, security tools, IDS tools, packet capture tools, etc. And you deploy passive optical taps or span ports at places in your network where you can get the most bang for the buck. Because passive optical taps are very expensive. And the tools are very expensive. So you tend to do it at network choke points. And at those choke points, you get lots and lots of data. And when you're trying to troubleshoot or ID something, Sifting through all that data is very difficult. It takes time and it takes money. So here's Big Tap. The idea is that you take a span or tap port from every switch, and you place those into an OpenFlow switch. OpenFlow switches are relatively inexpensive. They don't have to be the highest end model. And you take those ports and you drag them down to your tool ports. And this allows you to direct the traffic from every switch, from every tap, into the tools that you want. What does this mean? You can start with a single switch. We call them filter switches. Take your top of rack, set up a span session, dump it into one of these switches. Do it from every top of rack. Configure the delivery ports, what tool they go to. And then go into the controller and say, hey, controller, you got all this data flowing into this OpenFlow network from these span ports. I really want to see all the information from VM7 going to host 4. And please send that to capture device 3. And you click go, and you get the data. It's a relatively simple concept, but it's not one that you can do without SDN. What are we doing next? I make no promises. I am not talking futures, even though it says it up there. I'd like you to take a look and think about all the applications that you've seen for SDN. And think about things like Google G-Scale, load balancing, firewalls, and everything that goes along with it. And you can imagine all the opportunities that a company like BigSwitch has to write applications. More importantly, our partners, because of the open nature of our SDN, are writing the applications themselves and then running it on top of our controller platform. So it's not just BigSwitch. What we're trying to do as a company is enable the virtualization of the network. We're trying to unlock unrealized value the same way that happened in servers and in mobile. The reality is that we are at the beginning of a very long road which will transform the way the networking industry works. And we are looking for your advice and help and guidance to tell us what we should do next. So please, after the meeting, if you have any input or any questions, find me. I'm a very honest guy. I'll answer things straight away. We're looking for your guidance and input to see where we can help. The Korean market for SDN is at its beginning. At BigSwitch, we've concentrated on the US, the UK, Japan, and Korea, because we believe that your market is as big as the others, and that it is worth our time and effort to do business here. And that this community here, sitting in this room, is going to drive the adoption of SDN into this economy. So I'm here every month, and I'm happy to talk to anybody. Any questions?
Thank you for presentation. My name is Ujitan from Hafeez. I have actually 2 questions. You are mentioning about the virtual network and the VLAN, and for overcoming limitation of 4K VLANs. You said you are going to use the virtual networking concept. Could you explain a little bit detail about what's different between the virtual network and VLAN?
Sure. OpenFlow, in and of itself, really has no concept of VLANs, right? It's a flat network. Packets are put on the wire, and you can do whatever you want with them. The recommended network, the ideal network deployment, is completely flat layer 2, single VLAN. The switches won't let you not create a VLAN, right? But everything's in the same VLAN. And the networking is 10/8, completely flat. The reason that we have VLANs, right, the reason VLANs were invented was to separate broadcast domains and to allow for two networks to coexist on a single switch, right? There's no need for them in an OpenFlow network. So everything's flat, everything's on the same VLAN. You enforce the broadcast limitations and the security limitations on the controller, because whenever the first packet is generated, the switch or the vSwitch has to ask the controller what to do with it, right? So, for example, in our enterprise controller, if you send a DHCP message, it is traditionally a broadcast message, and it is flooded out every port of the switch. We don't do that. We actually learn where the DHCP server is, and we take that packet in, and we place it back out on the switch on the port towards the DHCP server. It does not flood everywhere, right?
Okay, thank you very much. My next question is, in your slide, there is a picture that the multiple controller is organized in hierarchical manner. The right-hand side slide. How the top-level controller can control low-level controllers. So in between the control, there is a hierarchical relation, right? Is there any definition for controlling the high-level controller can control the low-level multiple controller? Is there any definition of the protocols or API in between?
I apologize. The slide is a bit unclear. On the pure OpenFlow side, these are actually OpenFlow switches, not controllers. From our perspective, we, on the enterprise controller, have high availability built in. The underlying architecture of the controller has a shared database of an eventual consistency model, which means that we can maintain state on multiple controllers about what's going on and achieve consistency as an HA platform. Today, this is done in active standby mode. The future is active, because that's what people demand. As far as the redundancy mode, there are things in the OpenFlow standard for how a device talks to a controller. Whether that be serially, as in I configure 2 IP addresses and it picks one, or it can be controlled by 2 controllers at the same time. Those are covered in the OpenFlow stack.
네, 저는 오픈플로우에 대해서 잘은 모르겠는데요. 여튼 이런 버추얼라이제이션에서 가장 중요한 문제가 일단은 어떤 퍼포먼스 관련한 문제라고 생각하거든요. 근데 세션을 듣다 보니까 일단 컨트롤러가 기본되는 어떤 하위의 스위치들을 컨트롤할 때 일단 가장 먼저 첫 번째 패킷을 가지고 얘를 이제 스위치에서 컨트롤러에게 어떻게 얘를 컨트롤할 것인가를 이제 물어보고 이런 식으로 이제 컨트롤을 하는 것 같아요. 그런데 이게 소프트웨어적으로 가상화된 형식으로서 퍼포먼스 이슈가 생기는데 이렇게 매 패킷마다 이제 컨트롤러를 통해서 이렇게 패킷이 컨트롤되는 이런 아키텍처 하에서 퍼포먼스 이슈를 어떻게 해결해 나갈 수 있을지 그런 문제에 대해서 한번 알려주세요.
So I get this question I should write slides on this. It's a valid question, and when I originally started talking to BigSwitch about OpenFlow and talking to Kyle, the first time I met Kyle, one of the founders, was a year before I joined BigSwitch, and I spent the entire time arguing with him about the performance of the controller and how this would work, and I was pretty skeptical. The reality is that the way a switch works, okay, is that you have a control plane, and that control plane exists on a CPU and a switch. And if the switch doesn't know what to do with it, a packet punts it to the control plane. So if you run OSPF on a network, it's running on that control plane. If you run spanning tree, it's running on that control plane. Okay? The ability to scale that is based on the CPU of the switch and the bottom and the path between the ASIC and the CPU. Okay? So you can see, if you're familiar with networks, I'm sure we've all built networks where you've had an OSPF change event take down switches, right? Because they can never converge because the CPU wasn't fast enough, right? There is no difference in using an OpenFlow except for the fact that it turns out that the average CPU and the average switch is some underpowered PowerPC or MIPS. And the CPU on the controller is a giant multi-core beast. And the performance of the switch, packet comes in, packet is kicked to control plane, sent to controller. Controller processes packet, sends answer back to switch. In testing with just our product, single core, 2 gigs of RAM, running in a VM, 1 million packets a second. I can crush every switch. My problem is I have to rate limit how quickly I send messages to the switches. The reality is, back, 15 years ago, 20 years ago, when people had this idea of using ATM lane, which was the first thing people could compare this to, the CPUs and the quality of the software just was not good enough. Today, the CPUs of the platform that runs the controller are so big and so powerful, right? I can buy a server today and buy a 40 gig card from Mellanox and put that in and run that at line rate. What size of network do I need in order to have 40 gigs worth of packet-ins? Right? The reality is that this is just not a problem. And I'm happy to prove it to you with test numbers. I was very skeptical of this too, and then I looked at it and I did the math and I went, okay. The server equipment is just so powerful anymore that the problem that we have is that the CPUs and the switches aren't powerful enough. And I can DDoS the switch. Was that a good answer? Or?
추가적인 질문 있으신가요? 예.
Thank you for your presentation. I have questions about your virtual network segment. As I know, for configuring the virtual network in current cloud architecture, they are using, for example, OpenStack. They are using Quantum API and configuring the virtual switch, BigSwitch, or physical switches to create a VLAN. That is their concept of virtual network. So, is there any difference for your virtual network segment with the VLAN? And if that is different, is it pure OpenFlow approach for creating the virtual network segment, or does it use some kind of legacy tools?
Okay, so first of all, I apologize. I'm gonna attempt to answer that, but I'm not the expert on the OpenStack implementation. The reality is that in OpenStack, what we do is we enforce the deployment of VMs through, so the OpenStack uses OVS, right? So you have a server either running Zen or KVM running OVS, and all the packets have to process through OVS. So in this model, you have one of our controllers deployed, and OpenStack creates tenants in the controller. Okay, so when you create an instance for a new deployment. Say you create a workload for a company called Pepsi, and you add 20 VMs. And then you create another tenant called Coke, and you add 20 VMs. Those can have the same IP addresses. And it's a flat VLAN model that gets pushed down. We're not actually creating VLANs or using any of those tools. It's completely flat. What happens is the plugin defines the tenant Pepsi and the tenant Coke in the controller and writes the access rules. And that is enforced at the OVS level. So when a VM on the system attempts to communicate, the packet goes to OVS. OVS asks the controller, what should I do with this? And the controller answers yea or nay. Does that answer the question?
Then how does the controller identify each VM using MAC address? This is just a flat network.
So the information, there's a tag that is pushed called tenant ID that is associated with the VMs. If you look in our controller, you will see a tag. That tag is associated with an IP address and a MAC address.
So does the BigSwitch controller involved in creating VMs and allocating the tag when the VM is created?
No, the OpenStack process creates the VMs. And we get all the information about that VM, the MAC address, the IP address, where it is. And we define that as an entity and apply rules to it. So in the case that you're talking about, the disambiguation is obviously IP address and MAC address, right, as the unique identifier.
Then that means the BigSwitch controller actually works as a cloud controller. If there's other controller that create the VM or and performs other operations, and if the BigSwitch controller performs take charges in networking, then that cannot be called as a cloud controller. But if it performs everything in the cloud, then
The underlying model is that you will use OpenStack as your orchestration tool, and you should not step outside of that. Right? I can't do anything about the limitations the cloud tools do that everybody uses. People are going to use VMware, people are going to use Citrix, or people are going to use OpenStack based on what their preference is. And there are different deployment models for that. What we're doing is at the underlying level is we're enabling the message that this orchestration tool created this entity that has this IP address and this MAC address, and it is a member of this tenant, and I would like to enforce the policy. The underlying mechanism for doing that is the vSwitches or the physical switches are controlled by the controller. OpenStack pushes through our RESTful APIs the information on the creation of the destruction of the VM to the controller. Right? You should not step outside the realm of OpenStack to make changes. Right? The whole idea and promise of this is that I have one centralized point that can control both. The problem that we have today is you don't have that. You have an orchestration tool that is not network aware. And you have to go to the networking team to do this. Right? What we're trying to do with OpenSDN is basically say that virtualization, whether it be a process on a server or the network, are the same thing, and they should be connected together, and they should have one tool to manage them. And that's how you get the return on investment, by marrying these two different control planes into one tool. Did that answer the question? Or? And our information on our OpenStack deployment is available on our website, and if you want to drop me your card, I'll send it to you.
질문 있는 분, 이거 끝나고 쉬려고 그러니까요. 있으시면 지금 해주시면 좋겠습니다. 없으시면 그 홈페이지에 남겨주시면 저희가 다음 주 정도에 혹시 배너링을 해서 저희한테 보내도록 하겠습니다. 토끼샷.
Thank you everyone for having me.